Hello everyone, I am Mohan. I am currently pursuing bachelor's degree in the stream of computer science and engineering, specializing in artificial intelligence and machine learning at Vasant Venkatarajan Institute of Technology, Andhra Pradesh, India. As a part of our R20 curriculum, we have to do some major project, and for that, we have decided, let me introduce my teammates. My teammates of first me, and then second one is Sai Kumar, who has contributed his entire efforts in building the deep learning model, which has to be integrated to the website. Third one is Hemant Krishna. He has contributed in making our research paper to submit for conference, getting done for the right time. And and the lastly, the Funny Bhargav. He has contributed in EDA, which is a major step in data preprocessing in building the model. Like uh, like as as most of the developers, we started like we started searching for the problem statements which suits for us the best to implement the solution to the users in the real world scenario. Like and in that process, we ended up with picking up one problem statement from the SH, which is from the year SH 2022, and problem statement is a video metadata generation and classification using deep learning techniques. And let me give you the brief scenario of the what the problem statement is. Like this is the ISRO portal that is accessible to the users, but the client ISRO doesn't have the genre-wise video collection, which makes the users access the content or the video collection possessed by the ISRO organization or the outside members of the organization to access the what are the content they have collected or recorded till now, till the from the since the establishment of the ISRO, like a rocket launching, indoor control room, outdoor satellite launching, rocket launch, and all those things they're having as a data collection, but they are unable to present that data in an organized manner on the website. So the ISRO has decided as given that as a problem statement in the SH, and we grabbed the opportunity to build the solution for that to the ISRO, and we started with that. And let me give much more details about the problem statement. So I think mostly you got an idea of what a problem statement is. We are required to build the deep learning model for video classification and metadata generation. But as the data set is a new, and we are not having a designated data set, video data set for generating metadata. So we we have done some minor changes to the problem statement, and problem statement changes as this is the problem statement: video classification and a similar video segmentation system. And the techniques you use it for deep learning techniques used for video classification is LRCN, which is a cumulative of CNN and LSTM. And for similar video segmentation, we have used the Annoy algorithm, and we have decided the main objective is these two, like building the video classification model and similar video segmentation system. And third one is video search engine through the embeddings. And let me discuss about what are the functional requirements. We have drafted some 8 functional requirements. Let's get into each one. First one is a user identification and account management. like basically it is one of the requirement for any application for to let the users, only the authenticated users can access to their application. And for that we have implemented that authentication part as usual for registration, user registration, and users login with his credentials and reset password, and through OTP verification, these functional requirements satisfy these use cases. Next one is video upload and management. Like after after the user has logged in to his account, sorry, let me mute these notifications for some time. After the then other user has logged in his to account with his credentials, the user can upload his videos related to the ISRO organization, which are stored in S3 bucket, and those URLs or object URLs are stored in the MongoDB. This is because each and every user can upload and can see what the videos he has uploaded in the video gallery. And the third one is video classification. And here the user can classify the video into a specific genre, like a indoor control room or indoor launchpad, outdoor launchpad, control room, animation, etc. And fourth one is a video search. Like this is I can say this is a breakthrough because we are using here is a image search engine where the user can upload a specific image like a rocket or something related to the satellite or his organization. He can upload his image, and through uploading image, he can search the related videos based on the image he has uploaded. The fourth one is video statistics and dashboard. Like the user can access his stats, like a video stats, how many videos he has uploaded. As for now, I have not integrated like likes, views, and all those things. And genre-wise video collection statistics I have not integrated, but I have integrated like a total videos count in the statistics part. Next one is a recommendation system where the some videos are recommended to the user based on his videos and such based on his content i- that is specified to his account or the user. The similar videos are displayed to the user as a recommendations. And seventh one is video sharing and collaboration. Like in the video gallery page, there is an option for user through which he can share the public URL for his video, so that any his user, anyone can access to that video. And last one is the video playback and streaming. uh, after the after building the application, video playback and streaming is adds as a one use case where the videos are streamed without any latency, without any buffer, in a seamless manner. And that's all for this. And next one, I'm going to walk you through the design part, where we have designed some use case diagram, like what are the system design diagram UML part we have are there, like a use case, class, object, sequence, activity, collaboration, deployment. This is the use case diagram. This is a use case diagram. This demonstrates or the describing the users of the system, basically the user, general user, and the admin. But we have, due to the time constraints, we are we are bounded to the only the one user, and that to the ISRO user. And clearly can observe what are the use cases he can has, what the activities he can perform using our application. You can log in, upload, classify, view stats. You can view the recommended videos and search videos by upload, which is done by the image search engine. And this is a class diagram, overview of the class diagram, and demonstrating like what are the classes in our application. This is like each class, like what are the objects we are having, what are the methods we are having, what are the parameters, and those are access specifiers, whether the public, protected, or a private, or the return types of each methods, the function calls, everything. These are the like different classes. Next one is a object diagram. This describes the what are the how objects of different classes will communicate with each other using what using what parameters and use for with what function calls in a particular scenario based. Like first one is first use case is user authentication and account management. In that particular use case, these are the objects and the corresponding classes participate to satisfy the scenario use case. Next one is like the same way I have designed for each use case. What are the objects are communicating with each other using what methods, using what function calls. These are things. And next one is a sequence diagram. The only difference is object diagram and sequence diagram is the timely order. The the communication between the objects different objects of different classes or displayed in the timely order manner. First, like which object is communicating with the object of which class, and after that what is the response is giving. All those things is demonstrated in the sequence diagram. And the next one is a state chart diagram, and this describes what are the state changes in a particular use case for different objects, whether it's idle or a run or active or a start, yet to start. These are state diagram. This one is the activity diagram describing the scenario of a particular use case. What is the like conditional if clause loops and everything. It's basically the flow chart. This one is a collaboration diagram. How the objects are collaborating with each other to satisfy the particular use case using the function calls. This one is a component diagram. This showcases what the hardware components or the files we are having, what the database having, what the server, what the overview of hardware components and how they are communicating with each other. This one is a deployment diagram. This is similar to the component, but more than that, this deployment diagram leverages the components. And that's for now. And sorry, this is actual deployment diagram. Later on, we have designed some user interface, how it's going to be. We have designed some slides, which is done by the Sai, one of our team member, as dedicated his valuable time in making this done. He can have a look over what are the slides we're having we're going to have in our major application. Like this is a small screen, so majorly for our understanding what are the screens we are going to have in our final website. And next one is yeah. Uh, Now one of my team members, Sai, will explain how he has built the deep learning model. And over to you, Sai. You can
Thank
share
you,
your
Mohan.
screen
Yeah, okay.
and carry on. Just share your screen and
Is
demonstrate
it
your part.
visible?
Yeah, it's clearly visible.
Yes. Hello everyone. My name is Sai Kumar Sela, and I mainly contributed in this project by developing endpoints. Here, the project aim is to organize the video content of the ISRO documentary videos, and the videos should be accessible quickly by using the video search engine. And to create this kind of a system, we have divided this project into three different pipelines. Um, you might be asking that why you required three pipelines. Yes, there is a one reason. Because of if we created one pipeline, on that pipeline, integrated whole data and the model can be it is very difficult in one plate. Um, for example, the training to train any deep learning model, it requires GPU. So when you deployed this project into the production with a one single pipeline, there you need to have a high configuration instance. So to make it very simple and to reduce the cost, we have divided this entire project into three different pipelines. Here, what we have done is here we separate the training pipeline. We only turn on the GPU when we are ready to train the model. So that so in this way we can easily retrain our model. In this way we can easily retrain our model. Okay. After here, I'm going to explain how these three pipelines are going to work. Now let's see. Now let's see in the data collection pipeline. First of all, here you can see that in the data collection pipeline, first I will let you see. Right. I'll go to the data collection pipeline. Here, first of all, in the data collection pipeline, this repository is mainly used for collecting the data from the users. So here, how we are collecting the data is, first of all, uh, collecting the data and storing the data storing the data into the S3. First of all, how the data is organized, let's see. They have given the data set in this format. After that, we have performed some EDA. Let me share my screen. Let me. They have given the videos. They have given a plenty videos, but most of the videos are not usable for us because the videos has very short format. The videos has only 0 to 3 seconds only. So for that purpose, we are performing exploratory data analysis. In the exploratory data analysis, we filter the data and we clean our data. Wait a minute. Here, here in the exploratory data analysis, we have taken the data After we have used pandas library and the matplotlib library, and this all EDA is done by Bhargav. Bhargav will explain this exploratory data analysis part. Bhargav, hello.
Hello.
Yeah, I will pass
Hello.
the Bhargav, can you explain the exploratory data analysis part?
Yeah, let me share my screen.
Okay.
Is it visible? Is it visible?
Yes, it is. Yes, it is visible. Yes.
Yeah, it is
Yeah.
visible.
So as my friend has explained about data analytics, let me explain about how we have done the process. So we have imported packages such as pandas as a PD and matplotlib.pylot as a PLT and other imported files which are necessary to use. And we have read a CSV file, video classification.csv, which contains data. And here we have named the every category like logos, animation, indoor lab, and outdoor generics. All other videos in a specified manner with attributes. Um, so there are approximately 3,600 videos with 30 unique categories. It does not contain any null values. So, and here we have in this graph we can show that we can observe that most of the videos are animated. Indoor labs, animation, indoor labs, outdoor launch pads, and there are very less videos on airplanes, skies, and helicopters. So we can remove those categories which have less than 10 videos. So we can this data is consisting of raw data. So we need to extract it in order to create a specific data which consists of only related content which is related to ISRO. So we have done it here. So and nextly we can see that there are only 719 videos. If we have extracted the required data, there will be approximately 719 videos having greater than 5 seconds duration. With the small duration video, we can we can't get the accurate uh, result. It may be possible in the change of the category for every second. So we should consider the large duration, so we are using long duration df is equal to which filters data frame from videos with the duration greater than 5 seconds, which will increase the user friendliness. So give me a sec. I'm having some problem with my laptop. Just 1 minute. Just give me a second, please.
Yeah. Okay. Okay. It's fine.
Sorry for the inconvenience. Let's continue the topic. Sorry. So as I'm saying that we are decreasing. So there are n number of videos. So we are what we are doing here is we are extracting videos which are less than 5 seconds. So we are having only videos which are greater than 5 seconds or with greater than 5 seconds, so that user can interact with the software or with the web application which you are currently creating. So as we can see here, uh, see class label is equal to long duration, which we have which I have explained in the uppercase, where it will clear the videos which are less than 5 seconds. Here in this graph we can see that now we can observe that the categories such as airplane, airplane traffic, sky, hospital and outdoor interior composition frame and forests are having less than 5 videos. So above above this program or this program, what we have done is we have extracted the videos which are not related to this content which we are creating. So here we are creating get the classes that have less than 5 videos. So future here the categories which has less than 5 videos having 7.9 seconds average duration. So what we have done here is we have deleted the 5 seconds videos, and the average videos in this data are minimum 7.9 seconds. So we need to categorize them as well. Future engineering, let's consider only set of videos which are having greater than 5 seconds duration and having each category should contain at least 5 videos. So we can remove some of the categories that have less than 5 videos. Here we are get the classes that have less than 5 videos. So uh, so the process here, basically the process here is we are deleting the videos which are containing less than 5 seconds videos, and we are having average number of videos are 7.9 second videos. So we are categorizing, so there are n number of categories such as satellites or indoor work or indoor labs. There are n number of categories. So what we are doing is categorizing them in every way, so that in every category we are having at least 5 videos. Um, so this is about data analytics, and my friend, my team leader Mohan will explain uh, about the other concept that we will be discussing in a few seconds. Thank you, Sai Kumar.
Okay, thank you, Bhargav. Excellent work. Let me explain how data collection pipeline works. Here I'm showing that. Is it my screen visible? Sorry,
No,
Yeah, it is
not yet. Yeah, it's visible.
wait. Is it now visible?
Yeah.
Here
Yeah, it
I
is
discussed. Yeah, earlier I'm discussing about data collection pipeline, but I'm not telling about how it works. I will show you the code demonstration. Yeah, it is. Here, here in the data collection pipeline, I'm using in the backend, I'm using a fast API framework, fast API framework, and I'm storing the data in the MongoDB and S3 bucket. I'm storing the labels in the MongoDB, and I'm storing the videos in the S3 bucket. I will show you in few minutes. Here you can see that I have created seven routes. In this route, I can clearly explain each one of the route. Here, you can see that the fetch label, the fetch route. The fetch route is mainly responsible for fetching the labels which are stored in the S3 bucket. I will return the labels. Here you can see that the labels in the MongoDB. There are 5 labels in the MongoDB. You can see these labels: animation, graphics, indoor control room, outdoor launchpad, and person closeup. After that, you can also add new label. For example, if I want to add any new label, like for example, like person closeup, like aeroplane, you can also add this label in future by using this route. After adding this label, you can also upload the video with these routes. You can upload single video or a list of videos, and these uploaded videos will be stored in S3 bucket. I will show you where we will store it. Here you can see that the videos are stored label categories wise. In this way we can collect the data from the users. After collecting the data from the user, after this pipeline, we are storing that data in the Amazon S3. After storing the videos in the Amazon S3, and we take that data in the training pipeline. I will explain training pipeline in few minutes. Wait a minute. Yeah, this is it. Here in training pipeline, we follow MLOps level 2 Google MLOps level 2 architecture. In Google MLOps level 2 architecture, what they said is,
Sai, just give a brief on it.
yeah, I will explain. Yeah, sorry, it is level 1 architecture. We follow level 1 architecture. In this machine learning plan, in the training pipeline, first of all, we collect the data from the data collection. In the data ingestion part, we collect the data from the Amazon S3. Here we seen the data stored in S3. So we retrieve the data from the S3. We retrieve the data from the S3 in the data ingestion part. We validate the data. So before validation, we split the data into train and test data. After that, we validate the data. For example, if the data is not related to that category, so we stop the training. So we stop the training in the data validation. And again, we have also added some constraints. For example, in each category, there should be at least equal number of videos. For example, in each category, there should be at least 30 videos should be there. So that if it is not there, then in that case, we stop the training pipeline. So in the data validation, we use some constraints. After that, verifying the data, we transform the data to the model, and you can see that the artifacts in the model training pipeline. Here you can see that I have these are the artifacts in the data ingestion. I have I retrieve the data from the S3. Here these are the file labels. In the file labels, we have videos. After that, we have performed data validation. We have in the data validation, you can see that the valid data is animation. In the animation, you can see only the valid data. Okay, there are approximately in each video in each category there are approximately 15 videos, 30 videos are there. After that, validating data in the data, and we are also get the labels from the MongoDB. So why we are storing? You might be asking that why we are storing labels. For example, in your future, if you want to write any new label, you want to store videos with a new label. For example, with a aeroplane videos or a rocket type of videos with a new category, then you might need to again change the architecture of the model, right? So at the last layer, you have to assign the number of labels. So for that purpose, we have to store the labels in the MongoDB. So after retrieving these labels from the MongoDB, after performing the data validation, I have performed a train and test split. The train and test split, I have splitted the videos into train and test with each frame and storing it in the NumPy format. After that, after the data transformation, what I have done is, after data transformation, we performed model training. In the model training, we were using LRCN model. Model training. Here, we are using LRCN model. LRCN is basically it is a combination of CNN and LSTM. So what happened in the LRCN is, first of all, the main part is the convolution layer. Here we are using some convolution layers. These convolution layers are responsible for extracting the spatial information in the videos. After that, we are using LSTM to extract the temporal information from the video. So which is nothing but a sequential information, right? Every video has a sequential information, right? So we have to capture that information as well with the LSTM. So after that, finally we are using activation as a softmax, and with a dense layer of number of labels. Number of labels here is 5. After creating this architecture, we start model training. Model training using GPUs. After model training, we are storing that model in the S3. We are storing that model in the S3. Before storing the model in the S3, we need to first evaluate with the previous model. If the previous model works very well, and then we will not consider the latest model. If the previous model, if the latest model is better than the previous model, then we consider the latest model. Here you can see that in the model evaluation, artifacts will here I am returning the report. After that, here I am also storing the embeddings. So embeddings are nothing but wait a minute. Here I am telling earlier I am said that we have also performed various search engine, but you don't know how to search how to implement this video search engine. So to implement this video search engine, so first we need to extract the embeddings of the each video frame. Okay, how we are extracting the embeddings from the video is this in the model architecture. In this model architecture, we extract at the last layer. We stop this last layer. At this we stop after stopping this last layer, and we get the model embeddings. We get the image embeddings from this layer, and we are storing that embeddings in the MongoDB. We are storing that embeddings in the MongoDB. I will show you. Here you can see that the embeddings. Here these are the embeddings of the each video. There is a 32 size. You can clearly see that the 32 size of LSTM. Okay. So here we can here in this way we can store the LSTM. After storing in this way we can store the embeddings. After storing these embeddings, we need to perform the similarity like question similarity. So we have to perform that similarity type. So to perform that to get the nearest neighbor videos, we use Annoy algorithm, which is developed by Spotify. So Annoy algorithm is basically as an it is an advanced version of ANN. ANN is nothing but an approximate nearest neighbor. So you might be asking that why don't we use KNN? So which is a K nearest neighbor. So but what we have a problem with KNN. What is that? Uh, in KNN, the time complexity to get the top K nearest neighbor is order of n square. So so it is very time consuming with the KNN. So we are trying to reduce the time complexity by replacing it with the ANN. In the approximate nearest neighbor, we have only log time complexity. With the log time complexity, we can easily retrieve the similar content of videos. So that's why we are using ANN and Annoy algorithm to get the similar content of videos. Okay. So after performing this model training, we store that model. Uh, we store that model in the S3 bucket. We have stored that model and artifacts of the embeddings. All those embeddings and artifacts are stored in the uh, S3 bucket. Here you can see that the artifacts are stored in zip format because the file size will be reduced with by using the zip format. So yeah, with the zip format, we can easily download the files also. After performing the video, after completing the training pipeline, next we have build the prediction endpoint. In the final endpoint, there we have there we can there the user can interact with the user interface. Here we collect the data from we collect the model from the S3. After fetching that model from the S3, we perform the some data transformations to the input which is given by the users. After performing some user transformation, we given the transformed what is that transformed after transforming data, we given the transforming data to the model. After we after giving that input to the model give the predicted class, and a model gives the similar embeddings. With the embeddings, we can search those embeddings in the ANN with the Annoy algorithm. Annoy will give the top 10 top 10 similar embeddings, which embeddings are nearest to the input embedding. So we take the most similar and top 10 nearest neighbor embeddings. So those embeddings should be presented in the user interface. I will show you the demonstration also. Wait a few minutes. Okay. Here you can see that the user can also upload a video or a image. I will give you. I'll give you this input. Basically, it is an indoor control room. Let's see how it predicts the model. How the model will predict.
Sai, on which Docker image you are running currently?
What?
On which Docker image you are running? Either V1 or the latest one?
V1.
Okay. I think the V1 would not return anything.
Wait, it will fetch the model from the S3. In meantime, I will explain how we deployed this system into the AWS platform, AWS cloud platform. Here, first of all, we have Dockerized, we have containerized this whole system using Docker. So here in the Docker file, we have used multi-stage build. In the multi-stage build, what we have done is, first of all, we initially created Docker image, but it has a Docker image size of 3.78 GB, which is very huge, and we are unable to store the Docker image in the Amazon EC2 instance. So we are trying to reduce the Docker size. So to reduce the Docker size, we are using multi-stage build. So in the multi-stage build, what happened in the multi-stage build is, so first of all, we take the base image, we take the Python 3.8.18 as a base image. After that, after taking the base image, we are in the second stage, we are using a slim base image. We are using a different base image, and which has a less sized, which is a minimum sized image, and it is in this base image, and we configure all our system in this base image in the stage 2. After that, by using this multi-stage build, we can easily we can reduce the Docker size. So with the by reducing the Docker size, we can we have optimized the cost also. I will show you. Here you can see that here in this image, you can see that initially the Docker image size is 3.79 GB. After that, we are using multi-stage build. The image size will be reduced to 2.28 GB, and which is around 1.5 GB, right? So by reducing that size, so we can easily deploy this Docker image into the EC2 instance. Okay. So to reduce the project cost, and we were minimizing this Docker size. Okay. And how you might be asking that how you are deploying this application. So here we are using GitHub Actions for the CI/CD pipelines. In the GitHub Actions, we created one workflow. In the workflow, I will show you. First of all, in the GitHub Actions, we created workflow. In the workflow, what we have done is, first of all, in the AWS console, we have created a one user with the IAM user. The IAM user has a least privilege, and he has a rule. He has an permissions to the Amazon S3 and Amazon EC2 and IAM. So these three and Amazon ECR. Sorry. So these and he can access these three services to run these applications, to deploy this application. So the here in this CI/CD pipeline, we run that continuous integration. In the continuous integration, we take the Ubuntu mission from the GitHub Actions, and we run some of the echo commands in that GitHub Actions Ubuntu file, Ubuntu base image. After that, in the continuous delivery part, we have logged into the EC2 instance after using the AWS credentials. First of all, we should need to create the AWS EC2 instance in the AWS. After creating the EC2 instance, we should log into the EC2 instance using SSH by using putty using putty. After login to the EC2 instance, we should need to install some of the we need to install Docker. We need to install AWS CLI to run the commands of AWS commands and Docker commands. After installing those commands, here I have also provided the script what you have should install in the server. Here you can see that you should install the Docker and you should install the AWS CLI. You can use these commands to install CLI and Docker in your EC2 instance. After that, you have to configure the GitHub actions with the runner GitHub runner configuration. You can configure these settings in the settings. You can see this in the Git actions. Go to the runners. You can create a new runner, self-hosted runner. There you can get a list of commands. You can run those commands in the in the EC2 instance. Okay. In the workflow, after installing the Docker and the AWS CLI, you have to run some commands. You have first we have to first we have to log into the ECR. Okay, sorry. First we have to log into the ECR by using the AWS access KID, secret key, and AWS with the AWS region. After login to the ECR, we have to build the Docker image and push the Docker image into the ECR. So you can run these commands: Docker build -t, ECR registry name, and ECR repository name. You can find these registry and repository names in the Amazon ECR. There you have to create a new repository. So you can store these secrets in the GitHub secrets. After storing the secrets, you can configure you can access the secrets by using this $ symbol. After that, you can run Docker build command. After this workflow, you can run Docker GitHub Docker push command. The Docker push is basically after building the Docker image, the Docker image will be pushed into the ECR repository. After pushing the Docker image in the continuous deployment, you can see that clearly runs on self-hosted, which is the self-hosted is nothing but the GitHub Actions runner. There earlier as said before, in settings you have to set up a runner, right? Okay, in that runner, these commands will be run in that runner. Here in the continuous deployment, here you will again log into the ECR with this command. After that, you will pull that image from the ECR with this sudo docker pull command. After that pulling, pulling that image, if there is any old images present in that instance, you can delete those images, and after that, finally you can run Docker run command by using these environments. You have to give these environments to the Docker image to run the Docker image, because because you need to access the S3 also. Okay, so in this way you can deploy the EC2. You can deploy the application, web application in the EC2 instance. But there is one disadvantage also. With this approach, you have one disadvantage. What is the disadvantage is the main disadvantage is, I'll explain you. Yeah, there is a downtime. There is a downtime issue. The downtime issue is, for example, in EC2 instance, first you will run the Docker image. After running the Docker image, you need to delete the previous Docker image. In meantime, there is one downtime issues, right? For example, if a new Docker image will come into the EC2 instance, the old Docker image should be deleted. In this timestamp, for the Docker image is deleted and the new Docker image is added, is integrated into the instance. So in this time, so there is if the Docker image is deleted, there is nothing to show on your on your application. So if there is nothing to show, then your web application will be instantly shut down. So that downtime issues will be resolved with the other approach. So we have also followed another approach. So first of all, what we have followed in the first approach is it is a recreate approach. Recreate approach means if the version A, first of all we deployed the model with the version B. After that, we delete the version B. Then we installed version A in that model. So with that approach, there is a downtime issues. So to overcome the downtime issues, we have also followed another approach which is called as blue-green deployment strategy. With the blue-green deployment strategy, we have zero downtime issues and quick rollback. Okay. So what happened in the blue-green deployment is, so we run our applications on the EKS cluster, Elastic Kubernetes clusters. We run whole our application in the EKS cluster, and we create some replicas. For example, we have created 4 replicas. We have first of all, for the version B, for the previous version, for the old version, we have created two replicas, and for the latest version, we have created 2 replicas. If any of the version will fail, then we will switch the traffic to the latest version. Okay. Here I will show you the demonstration also. I have also recorded the video. Here you can see that we have switched that traffic with the ingress. I have created load balancers also. Here it is a previous old version. It is a blue version. I call it as a blue version. Here you can see that there are 4 replicas are running currently. After that, I apply green ingress, which is a new version. You can clearly see that. So it is an old version, and now you can clearly see that with zero downtime, you don't see any issues, right? With the zero downtime, you can easily switch the traffic to the new version. Okay. And you can also roll back to the previous version also. If there is any issue with the new version, you can also roll back to the previous version. Here you can see that I will roll back to the previous version, blue ingress, the blue ingress. Yeah, here you can see that we can easily roll back to the previous version also. So in this way, we have developed the application with very by using very optimized. We have followed very optimizations steps, and our application is very flexible, and it has a zero downtime, and it has rollback capability, and it provides a consistent user experience also. And this overall API is integrated to the our major web application, which is developed by our team member Mohan. He will explain how our new web application will work. Okay,
Yeah, thank
now
you,
Mohan will
Sai,
explain how
for
the whole web application will work. I'll stop this training.
yeah, sure.
Okay, Mohan, you can explain.
Yeah, thank you, Sai, for clearly explaining how the training and the data collection pipelines and the prediction pipelines in using the 3-phase pipeline, and how you have deployed using a Docker, how you have containerized that, and by using the sophisticated methods like optimal way, using a blue-green deployments. Kudos to you. And now I'm going to walk you through the website, how it looks like. That developed parallel to the functional requirements, which I have explained to you at the starting of the demonstration of our project. This is how it's look like. This is the UI of the website, and like how I have built this. I have built this website using the main stack. Like why I have used the main stack as a if I have used this HTML6 and JavaScript, these things are already outdated, like not clearly acceptable in the current industry because they are working on a main stack or the main stack or the Angular, React. Everybody is asking those frameworks. Have you worked on those frameworks in the interview? So if we have worked on like a latest tech stack using main or a mean, we are able to express our strength or our capabilities to the interviewer, so that they can know that we have already worked on a main stack or those related frameworks like Node and React and the databases like MongoDB. And now, someone confirming if my screen is sharing properly.
Yes, Mohan, it is
Hello.
visible.
Yes,
Yeah, it is visible.
Here you can clearly see that I have developed on the back end using the Node and the front end using the React. Let's discuss each one in detail. In the front end, like front one is React, and have included all the components in the SRC folder. And here is the components. Let me give the brief overview, like what are the components in our web application. Like these are the components we have going to have. These are the roads we are going to have in our web application. Register, login, forward, password, change password. This one is a video upload, video gallery, video search, video classify, and analytics. This one is profile. And let me explain about the first component, or register. Like firstly, I have inputted all the required components or the images or the headers or the libraries required to satisfy the user registration use case. This one is a const. This is a component that's handle the user registration part. This one is a use formic, used for state handling, which are used to transfer the details entered by the user into the backend endpoint. This is recording all those stuffs. This one is the actual part we are returning to the register endpoint. Enter your details, all those things. This is a normal register form. All the real world websites are having like a first time details, all the register user details. We are going to collect all those details. And this is recording register. And what we are doing is using the user state formic, we are using the helper functions here. This is a helper function. Register user is a helper function that is going to send the details entered by the user using axios.post request to the endpoint register, which is implemented in the controller as a controller in the backend. This is the helper function that is taking care all the details of the user. This is the endpoint. I have to I have to send the details of the user to the endpoint API.register. After I'm collecting all those data, and I'm collecting the two values, basically the username and the email, to send the confirmation mail to the user after successful registration. And for sending the successful confirmation mail, I have used the register mail endpoint and using the parameters like username and email or the text message what I have to send in the body to the user. What the user is able to see in his inbox is the message, and I have performed error handling if runtime errors or the uncaught errors are taken care. Those will be caught by the toast messages. Next one is I'll go into the endpoint, register endpoint. I'm going to explain like what I'm doing with these values that are coming to this endpoint. Sorry, we'll go to the app controllers. This is one is the in the backend. In the app controller part, we are having the register controller function for handling the details. Actually, I have to show you the root. Where it is? Yeah, here it is. Yeah, these are the actual routes we are having in our application. And for each route, take for instance, consider the register route. The controller function that handles the data or the values, either it is a request or the response or the handling, is taken care by the register function, register controller function. Let's go to its implementation. Here is a control register control function. Like what I'm doing is previously I have sent the details what our user has entered in the registration form, and from the request, from the body of the request, I'm collecting these values: first name, last name, email, and username and password, and have check and have performed some checks. If the username, what if a user is already exist, uh, uh, and I have done that using the username, and you can find the if we have already found that username, we can return user is already exist. Please use a unique username. If the email entered by the user is already exist in our database, then we can let the user know that use enter email. This one is for password encryption. What I have already previously said that is I have tried to implement the authentication part to the fullest, but not in the real world scenarios exactly. But what I have not implemented is like whether while the user send the email is directly not get into the Gmail inbox what he has entered, but it will be sent to the Ethernet mail, which is mostly used by the most of the developers while developing web applications. And here I'm hashing the password using the bcrypt, and the hashed password is going to be stored in the MongoDB, and like this. Clearly, you can observe like these are the videos. This is the users collection. Yeah, and the password is getting encrypted, and the hashed password is going to be stored in the MongoDB. And let's get back to the implementation part. And after storing those details, user details successfully in the database, we are uh, going to let the user know that his details are successfully stored and user register successfully with the message. Otherwise, you can display some could not register some error message to the user to enhance the user experience. And registration part is completed, and next one is the login part. Let's get back into the front end component. Login. is the same to the same as to the registration. I have handled in a similar way, but what are the forms we are having, the front end components we are having? Either the data entered by the user is collected by the component, and state handling is done by the use formic, and those data is sent to the backend endpoints, which I have clearly shown before using in the root.js, and the specified action is taken in by the controller functions. And the meanwhile, if any checks has to be done, we can has those has to be performed in an appropriate way. In the login part, actually we are validating the values or the details entered by the user, whether he's authenticated or not. Basically, I'm using only username and the password to validate the user. And this one is a helper function for that, verify password. Here, the details what user has entered, the username and the password, are being sent to the endpoint login using the post request. And then let's go to its endpoint, login endpoint. Here is the login endpoint, and the control functions like a verify user and the login are are responsible for handling the server side part of the login. And let's go to its implementation one by one. Here is a verify user. What I'm doing is what the details are entered by the user, like a username. If I'm accessing that username from the request body, and I'm going to check whether the data, whether that username is available in the database or not, whether is registered or not. If he is registered, and we can probably go to the password check. Otherwise, we can return that we can't find the register. Please register. Next one is login. I think so. Let's confirm once again. Here is the login. Go to its implementation. The control function login deals like a authentication part, how to validate the user using the password, whether the password entered by the user is appropriate or not. What we are doing is we are storing that previous password in the database, and what the user has entered during the login, it is a password, and actually we have already stored the one password while the user is registering in the database. Actually, we are storing the hashed password. What we are doing is we have to in de-encrypt the password using the bcrypt, and we have to compare those password whether there is a match, where then user is allowed to access the application. What are the features or use cases is have our application is happening. And after the successful match of the password and the username, then there is and I'm generating the token to pass to pass this token to each and every endpoint of our application, though, so that only authenticated users are allowed to access our functions or the features of our application. And those and that token is expired within 1 hour, and after 1 hour the session will be recreated and section will be clear, and all the variables or the token variables are getting clear from the local storage on the auth store, and the user will be kicked out of the application and redirected to the home page where he has to log in again into his account to access the features of application.
Mohan, can we change that expiry date? Can we change that expiry time?
Yeah, we can. It's up to it's up to us. It's up to us. We can mention any time. Also, what are the you can mention the time either the 10 minutes or the 5 minutes. After the specified time, the user will be automatically kicked out of the session and redirected the home page.
Okay, okay, thank you.
And let's discuss about what are the features I have implemented, like user upload, how the user can upload the videos, and for that, there are corresponding components of video upload or JSX. So the workflow is similar for each and every use case, or what the helper functions, what I'm doing, what the control function is doing, how the data is fetching is similar. Just the state handling is handled in a different way. You can due to the time constraint, I'm unable to explain the line by line. I'm not going to deep dive into the explanation part. If you are interested, you can clone our repository from our Git repo, and it is public. You can verify how we can can access to our content, how we can access to our code, how we have developed entire application. This is a component that handles the file upload. And next one is a video gallery. Like this one is like here. What are the videos that are uploaded by user that are handled by the searching for the helper function. Yeah, here it is helper function. Let's go to its implementation. Whatever the file he has entered. Like previously, I have used the base64 format, but no, not able to convert due to the I'm getting like a large payload error. So I'm not converted. I have used the entire video file into the ST form and storing the file URLs in the MongoDB, which I'm going to explain in the meanwhile. I'm correcting like a file username in the title. Like you will get to know in the further due while I'm going to demonstrate lively with the website. And for the endpoint correspond to is upload endpoint. And here is upload endpoint, and the control functions responsible for is and user is allowed to upload only a single file at a particular instance, and the control function that handles upload is upload video. Here, what is using what I have doing is here. Let's have a look. Like I'm checking the file mimi type, whether it is MP4 or MP3. I'm accepting only MP4 format because it is a video. Like what I'm storing all those request data that I've got to the upload endpoint. I'm accessing these values. I'm storing the variables. And I'm going to store that video file into the SD bucket. You can watch any video, any tutorial. There is a more community AWS community builders or the AWS heroes. They have demonstrated clearly how to create AWS bucket. You can refer those content. For time constraint, I'm skipping that part. And here is the actual logic how we are going to do it. How we are going to store the file uploaded by the user based upon his username in a sorted way. Meanwhile, I'm going to fetch the videos that are uploaded by the user in the video gallery based upon the username. That's why I have stored in the username directory. This is the directory where how inside of which directory the actual file, the video file is going to be stored. The first one is there actually in the in the AWS bucket. This one is the AWS bucket. These are the user names. And I have created like a specific directory for each user, and inside each directory, we are going to show the videos uploaded by the user, specific to the username, so that it is helpful for us while fetching the videos content based on the username in the video gallery. And this is a file URL. This is the public URL that we are going to store. This one is a video model, is to show the videos in the MongoDB collection. That's it. Next one is a video gallery. Using the video gallery, I'm fetching the videos that are stored in the MongoDB or the S3 bucket using the based on the username. Next one is a video search. Previously, my teammate Sai has clearly explained how he has implemented the video search and video classification part. What I've done is I have integrated that one into my main stack. Just what I have created one component, and I have redirecting whether user clicks on some specific endpoint. He's getting redirected to the endpoint specified by the SAI in the prediction endpoint, like the search. This is one endpoint that is handling video search. This one is a video classifying. This one is a home route. And next one is this one is a sample. This is what are the services that we're going to offer to the user, just that are displayed in the home page. These are the services. And this one is a profile. Like for every real world applications, the profile is common. Every user is going to be look what is the username is, what with what mail he has registered to this application, and what are the videos uploaded by him, and he can update his profile. And user is allowed to update only his first name and last name, because I have limited the user not to change his mail and username during his accessing to over the application. This one is a general not form. If he entered is any different endpoint that is not on our application, he is just the page not found screen will appear. This one is in analytics. What are the analytics is going to the user is going to get. Only the uploaded count will be shown to the user as an analytics part. This one is avatar drop down. When the user clicks on his profile, the drop down will be appear where he can access features of our application. This one is the home screen. Due to the time constraint, I'm not able to go explain you each and every part. This one is the authentication part. This one is a JSON web token. How I am storing that. How I have implemented the thing is part using the JSON web tokens and storing those tokens in the local variables. This one is a just to refresh the details. When the user refreshes the screen or the browser, he will be kicked out of our application. Just to clear the environment variables or the local variables, including the
Could you
token.
please run the application once? We can clearly, easily understand what you said.
Yeah. Till now we have have walked you through the implementation part. What are the backend,
Yes.
how I have implemented. Let's dive into the implementation part and really how our application looks like. This one is a front end. This one is a React API. Backend is this one is a running server connected and database connected. This one is a fast API that I have collected from that Sai Kumar. His actual application. Like let's check that the user is able to access endpoints or not. You can show that the user is not able to access endpoints of the pages without login. This is the home page. You can clearly observe like a hero section of our home page. This was the service section. What are the services that are provided by our application, like personalized video experience to the video gallery and institute classification system formed by the video classification model and the recommendations that tailored for the user that are tailored for the user and the speed optimized and the image search engine where the user can get access to the similar content by uploading an image within no time. Uh, that's how it is optimized. This is analytics. You can where the user can get the analytics on his dashboard. This is the video applications. Let's get explored. Now I'm going to register with a new user. Let's give some random name like let's give Hari. Last name is Krishna. Enter the email and you can enter any email. Harikrishna at gmail.com and the username must be like nine digits. Hari K at the rate. Not at the rate is not acceptable. Oh, only the alpha numeric characters are acceptable in the username. Hari K 1234. Yeah, it is 9 characters. Let's enter the password at the rate of 1234. Let's confirm the password once again. Okay, at the rate 1234. For login part, I'm storing these credentials in my notepad. This one is the password. This one is the username. And click on accept the terms and click on register. Yeah, the user is successfully registered. And now what you are doing is a login using his username. Now what the user will get is what I have told previously is the confirmation mail will be will be sent to the Ethernet mail. Let's check whether the here is a sign up confirmation mail. Yeah, Hari Krishna 120 is the username. Yeah, I have registered successfully to your application. This is a sign up confirmation mail. I have got into the Ethernet dashboard. Now let's log in with his credentials. And let's check whether the details of the Hari Krishna, whether the stored in the MongoDB or not. Let's refresh. And sorry for the delay. I'm running my application on the hotspot, mobile hotspot, not connected to the Wi-Fi. Yeah, here you can observe the Hari Krishna username. The password is encrypted password is here is the username, is the first name and last name. The user object is created successfully in the MongoDB. And next, I'm going to log in with using his credentials. Here is the username and the password is click on login, and he will be successfully redirected to the his profile where he can clearly observe what are the what his account details are, first name, last name, of the email, and the username. And next, let's upload one video. Let's get a random title. Let's enter Hari, and I'm going to upload one video. And I'm already having the video collection of the data set on which our model has been trained on in the VMGC dataset folder. Let's upload from graphics. Need the selected file and click on upload. The file uploaded successfully. Now we're going to we're going to confirm whether the user the video uploaded by him is actually uploaded in the AWS S3 bucket, and the file URL has to be stored in the MongoDB. Let's check that. For confirmation, I'm going to show this file name in the notepad. Let's go to the bucket, S3 bucket. We use the user. Let's refresh. Here is a Harike directory. You can clearly observe the video he has uploaded. He is successfully stored in the Mongo S3 bucket, and the video is scene 107. Yeah, scene 107. The exact video is stored in the bucket. And next, we will check that in the MongoDB, the video collection. Here, actually, I'm showing the title, file and the username, which will be visible to fetch the data based on the username in the video gallery specific to the user. Yeah, here is a title. Okay, here is the object URL, and this object URL is a public. You can access or you can share to your colleagues. And upload is successful. Next, we'll check whether the uploaded video is displayed in our video gallery or not. He has uploaded. You can clearly see the audio and the actually is as it is a React component. These are provided default in the browser, the Chrome browser. The download, playback, and the plain picture or will be taken care by the video tag. The volume, these controllers are will be handled over by the video tag in the React component. You can share. We can copy this URL and you can check whether this works or not. Yeah, you can get access to the content. And the next one is till now we have walked you through the video authentication is done, video upload is done, video classification, video search, which I'm going to in the explain you in the further due. And this is the video gallery, and you can delete. The video gets deleted from your account. Now let's check one more feature. The user is whether he's like a user is supposed to be enter is you upload an image to search the relevant content. Let's upload one in image. That's like let's check for rocket. Yeah, for instance, I'm uploading the rocket image and search the relevant videos based upon this image. Yeah, here you go. These are the videos that are matched your results based upon the rocket image. clearly displaying your search results, and that I'm going to return only the top 10 videos that are already stored previously in the embedded collection by the Sai Kumar. And next one is I can get back to this application. Let's check the classification. Here the user is supposed to upload the one video format. Here the format is MP4. So we have to upload one video. Let's upload one video in the VMDC dataset. Let's upload one video of an indoor control room. Let's check whether our model predicts correctly or not. Our classification model. Yeah. Congrats that your
Nice, Mohan,
classified genre
nice.
is indoor control room, and our model predicts correctly. And for the to improve that user experience, we have provided some recommendations based upon his that are similar to his video content, that are streaming content or the upload content what has done uploaded by the user. These are the videos that are recommended to the user. You can observe here all the indoor control room or the control room or the indoor meetings in the ISRO organization, because we have uploaded the video related to the indoor control room. And let's check the analytics part. Just for the due to the time constraint, I have bounded to the total uploads. Only the total count will be displayed. Not as not as real in not as we sophisticated as a real world scenario like in YouTube. Whatever the video streaming platforms like Netflix and YouTube offers, like comments, views, it is far way difficult to implement within the specified time that are given for us to implement this project. And aggregation components are provided by the React libraries to get the video count, upload count for the specific user based on the username. And the Harike has uploaded only one video. That's why he is showing only uploaded count. And that's all. And you can go to his account. You can and another one is the account management, right? He can update his username. And let's change his username as Hari Prasad and updated this and update successful. Let's check whether the update is reflected in the MongoDB or not. Actually, the first time is not getting stored. Go to the users collection. Go to the object Hare Krishna. Yeah, we successfully updated the username and the first name. And let's check. It is displaying. Just refresh. And now you can observe Hari Prasad Krishna. His username updated. Till now, I have walked you through the account, upload, gallery, search, classify, analytics, and whatnot. Our implementation has come to an end. I think so. Let's confirm once again. Yeah, that's it. And as part of our major project, we are supposed to publish one conference paper in the conferences like IEEE, Scopus Index, and Web of Science. And for that, we are not at publish our paper. Our paper has been modification has been finalized, and we are going to publish, or we are going to submit for our paper into the conference, most probably in the coming week. Let's get into the I'm going to walk you through the poster, how like a poster details it gives you it gives you a overview of what our paper is, how our research paper is written. We can observe the proper title is video classification and similar video segmentation system. And the others are me, V Mohan, Sai Kumar, and actually the paper part is is handled by the Hemant Krishna. The entire paperwork has done by him, and we are from the Department of Computer Science, Artificial Intelligence, and Machine Learning, as I have already said you before, from Vasudeva Venkatarajan Institute of Technology, Andhra Pradesh, India. This is our introduction of like as of our digital era. We are getting a large amount of video content, but the video content is not able to. We are not able to organize. We are unable to access the video content in an organized way. For that, our application, the classification model, like what model we are developed using LRCN, the community effect of CNN and LSTM, the video classification model, and the similar recommendation system, the video recommendation system by using the Annoy algorithm, which are clearly explained by the Sai Kumar previously, which are further will be explained by the Hemant in the further due. And here are the objectives. Like that our paper proposes a novel approach for a video classification and similar videos recommendation. And this is our model. This you can clearly observe the architecture of our model, how the input, the frames are sent to our model, and how the categories getting predicted of our model by our model. This is an algorithm where the p-mapping exists for the ISRO users and the topmost matched embeddings of the only 10 author-written user as recommendations. These are the and as of our data set is new, and they have to build our model from scratch, and we are now able to achieve only 60%, 67% of accuracy for our data set. And as we are not having a designated data set to train our model on the best using the best algorithms, as a so-called what are the state of art model accuracy, we are not unable to achieve due to these constraints. And clearly you can observe like training loss and validation loss for each categories: animation, graphics, indoor control room, outdoor launchpad, and the personal close-up. And in conclusion, how we have gone, how we have trained our models, and what accuracy we have able to achieve, and what our references we have collected till now on like video classification, action recognition, and the Annoy algorithm. All those things are clearly will be presented in the paper, which is will be explained by the Hemant, our batchmate. Over to you, Hemant. Like explain the research paper.
Mohan,
Yes,
before
thank you.
that, I want to add one more point. Wait, Hemant.
Yeah, carry on.
Could you please share that? Could you please share that presentation?
Yeah, sure. Is that the research paper? Poster?
Yeah, poster.
Yeah, go.
Poster.
Yeah, go ahead.
Yeah, one more point I want to add. So here we are using LRCN architecture, right? So for the video classification, here our data set is very different and it is very unique also. So that's why we are not going go to with any pre-trained models. We have also tried pre-trained models, but we get very less accuracy and we get very different results. We have tried ResNet also. We have tried other exception 3D models also, but with those pre-trained models, we didn't get better results. Why we are not getting better results is the reason is the pre-trained models are trained with the data set. The data set which is a different images, but that data set does not contain contain the information that we have in our own data set. Okay, that's why we have to select we have to develop a model from the scratch, and we have to use a new model architecture which is LRCN. That's why we go for LRCN architecture. That's why we don't go for any pre-trained model architectures. Yeah, that is one more point I want to add.
Exactly.
Yeah, you can explain, Hemant.
Yeah.
Yeah, Mohan, let me share my screen.
Go ahead.
Yeah, is my screen visible? Hello.
Yes, it is visible, Ahmed. Yeah, it is
Yeah,
visible.
yeah. As a previously Mohan said, give the
Sorry, Hemant. Sorry to interrupt. We are going out of time. Like, just give a overview, not get a deep dive into the research paper.
yeah, fine. Yeah. So as previously Mohan said, he was given the light introduction. Now let me give the a brief overview. Like what is our main agenda is to use the LRCN architecture for the video classification, and how we can achieve that, by how we can classify that, how we are going to achieve that. So let us see that. And not only the classification, we are also having another task called Annoy algorithm, which is also for a recommendation system. So for a recommendation system, we are going to use an algorithm. So let us see in a while. And this is a related work. Previously, like our people, we did the work on the ISRO dataset, but previously this LRCN architecture has been used by various authors, and they had published the papers. So we have used those references and their work as a pre-knowledge, and we have get some knowledge about the previous work that what they done. So based on that, we have developed our LRCN model. So if we are going to talk about the data set, so in the data set, we are mainly focusing about 5 categories. First one is animation, and another one is person close-up, graphics, and outdoor and indoor launchpad. So totally we are having 150 videos. So each category will have 30 videos. Okay, based on that only we have done our training part. And this is like an basic how you can see all these are belongs to animation, and these are belongs to graphics. And this is an indoor launchpad. So to visualize, I represent it like that. And the animation consists only the animated content. In that particular videos, we will have only the animated content. So in the person close-up, we will have the person close-up shots. So based on that only, we have developed our model. So this is about the data set overview. So videos per group is 30, and minimum duration will be around 4 seconds, but maximum duration today. But we are taking about the 6 frames per second. And when it comes to the proposed approach, so how we are going to approach to develop the model is by using the LRCN architecture. So and later we will discuss what LRCN architecture is. So first process is dataset pre-processing, so which is done by the Sai itself and Bago together. They have done this data pre-processing stage. So what they did is they divided that entire dataset into 2 parts. Like first one is for test set and another one is for validation set. So what internally happens is according to the numbers what they preferred, the data will be segregated, and then only the training process will be started. And this is how like it's a diagrammatical representation of how our proposed model will be work. So first one is the data, which is the videos, and what we're going to do is all this is pre-processing stage, where we are going to extracting frames and resize, and we are going to normalize the input images. And now what happens is after the pre-processing stage of those videos, we get the frames as an resultant. So this will be split into the training and validation set data sets. And first step is we are going to use the LRCN. So what LRCN will be is, here we can see what LRCN is actually. So LRCN is a combination of 2 things, that is convolution neural network and recurrent neural network, or it will be an LSTM also. So main agenda of this CNN is to extract the spatial features, and then it will be transform the input image into one-dimensional vector. So this one-dimensional vector will be used as an input to the RNN encoder. So which will be take care of the temporal dynamic decisions, which means that it's like a recurrent, like what previously happened. So all these things will be memorized by the RNN. So the combination of the CNN and this RNN will result of the LRCN. And next is this is how the architecture will be. So this will be the images. Whenever an image given to the model, first we have the CNN. So CNN will have around 4 layers, 4 blocks, where one is convolution 2D layer and batch normalization layer, max pooling 2D layer, and dropout layer. So once our input image passes through the CNN, then we go with the CNN is for visual features, and then one is sequential learning. What it is, recurrent neural networks, where LRCN will be involved. And then this is how it is all like parameters for our LRCN. So we have CNN, and then we have the RNN also. In the CNN, we have 4 blocks. This we mentioned here. And later on, we are processing 64. Yeah. At the last layer, we will be having a dense layer where we are going to use the softmax activation function. So for the category, so to determine which category that video belongs to, so that's why we are going to the softmax activation function in the dense layer. So the another important thing in our research paper is similar video recommendations by using Annoy. So why we need to use Annoy? Previously, we have the KNN. So KNN also is also for the similar video recommendations also. But what happens is for KNN, it has a time complexity of O of n square. So which will take a lot of time. For 10 videos, it would be fine. But when it comes to a large data set, so that was not the good approach. So that's why we are going to use the Annoy, which is having a time complexity of O of log n. So what is the difference between implementation of this KNN and Annoy is, what Annoy do internally is, it will start splitting the data set. Like if we have, like here, see, here we have an x-axis and y-axis. The blue points are various train points. And whenever a new point comes into the graph, so based upon the segregations, so there will be a various number of segregations will be done by the Annoy, by it internally. So there will be many parts. So it will be one part, and this will be another part. So part wise, whenever a new point will be included into the point, so the related, so the points in that will be also recommended for our for the user. Okay. So if whenever a user uploaded a new video which will be placed here by our Annoy algorithm, so in that region there will be around 2 videos. So these 2 videos will be recommended to by the seer. This video will be recommended to our user. Okay. So this is done by the Annoy algorithm. Yeah.
And basically ANN follows divide and conquer approach, right?
Yeah.
Yeah.
So this is the advantage. So that's why we are going to use the Annoy. Yeah, when it comes to the results, 80% was this is all about data set what we are working with. So total 150 videos, and which 80% means of 150, that is 120 videos will be used for the training purpose, and remaining 30 videos will be used for the testing purpose. And whenever we plot this accuracy models, so we have registered an accuracy around 66, which is nearly 67% accuracy. So this is a confusion matrix. So yeah, as regards to our accuracy, if you can see, there was a slight misclassifications. That's why the accuracy has been reduced. And these were the graphs. So around what it is about what is the total loss and total validation loss. And in this graph, we can see how much accuracy did we get is around 69. So sorry, I'm 67. It's around 67. Yeah, and that's about the result section. And when it comes to the conclusion, we have totally used this kind of technology this kind of tools, and achieved the 67% accuracy for our video classification task. Yeah, that's it. Thank Mohan.
Is it a test accuracy or a training accuracy?
Once again.
67% is a test accuracy or a training accuracy?
It
is a test accuracy, right?
It's
Test accuracy, right?
It's test accuracy. Yeah. Over to you, Mohan. Sorry, I think you're on mute.
Please unmute yourself, Mohan.
Yeah. Hi, all of you. Everything is fine. It's time to wind up. And Fargo has switched off his camera. I think he went to lunch, as is our lunchtime. Like as we are concluding our demonstration, let's express our gratitude to our head of the department, Suresh sir, who stand as a pillar for and guiding us throughout our project implementation, and our guide Deepika ma'am, who always stand stand as another pillar of support, and who always clears out doubts, and who helps us to come out of the errors we have committed, to implement our workflow. And that's how we came to an end. That's how we have implemented our deep learning model. Everything as first we have started with problem statement, figuring out how uh, how we can implement the major project in the best way. And later we have started on abstract part of what we are going to implement, what actually we are going to do. And we came out of a solution proposed approach and the classification model using the LRCN. After the several trials that are compatible with our data set, that all our work has done by the Sai has taken a lot of time, lot of effort in building that model as a three-phase pipeline. It's not that easy. MLOps is highly advanced, and he has tried his level best to make that done to the considerable amount of accuracy, not to the state-of-art model accuracy, not on like about 95%, as this is a non-dedicated data set. And I have built the web application using the main stack, and Hemant has contributed his efforts in research paper. And also each member of our team has contributed their efforts in making this project done within the deadline of 2 to 3 months we have provided. And every week we have gone through the reviews. And finally, we have successfully implemented our project. Kudos to everyone. That's it.
Yeah.
Bye.
Yeah.
We'll meet in another session. Another
Thank you,
time.
Mohan. Thank you.
Until then,
Thank you, Mohan.
keep supporting us. Bye. Bye, everyone.
Bye, everyone. Bye.